Hello, and welcome to another Unreal Engine 4 tutorial in which we take a look at the Niagara content examples. In the first video in this series, we actually took a look at the very last content example in this project. So for this video, I thought it would be fitting if we took a look at the very first one, which you can see here is this simple particle sprite emitter. And we're going to, as we did in the last video, take this emitter and what they're doing with it, the methodologies that they're using for this emitter, and try and make something interesting out of that. So we'll take a look here at what this emitter is actually doing real quick, and then we'll jump into actually changing it and turning it into something interesting that you could use in a game. So first thing you're going to want to do to get to the emitter is to click on the emitter and then click on this browse button here to find it in the content browser. And it's going to bring up the simple system here, which you can open, and then we'll take a look and see what it's doing. So you can see this is, as it says in its name, a very simple system. It's got a standard emitter stuff that you would want. It's got a life cycle. It just spawns 5 particles per tick. And then down here we have a few things that it's doing. So it's basically setting a lifetime, a sprite size, and a velocity. And it's just using the standard origin location, and the particles are moving up from there. So you can see they spawn at the origin and they just move up. And the one really interesting thing that they're doing here is that they're scaling it by a sine function. So that's practically all this is actually doing, is it's just taking the sine of the normalized age of the particle, so between 0 and 1, and multiplying that by 2.7 to get sort of a bigger size range. And then it is using that to drive the size. So you see as the particles live, they start off at like a normal size, and they get bigger, and they get smaller, and they get bigger, and they get smaller, because it's behaving like a wave, like a sine wave. So I took a look at a lot of different things I could do with this. But in the end, what I thought was most interesting was shaping particle systems using a sine function. So what we are going to be doing in this video is we're going to take a sine function, and we're going to use that to shape a particle system that will in the end look like sort of a thruster on a spaceship. So in order to do that, we're actually just going to take this particle system and reuse it in almost its entirety in a new project. So the way that we're going to do this is we're going to migrate it. So I have a new project set up over here in the first person blueprint. And what we're going to do is we're going to right click on the simple system, go to asset actions, and go to migrate. And then we're going to click OK. It's basically telling us here all the assets and dependencies that are going to be migrated. It's actually migrating literally all of the assets. So we're going to hit OK there. Actually, first, before I do that, I should enable the Niagara plugin in this project, because I haven't done that yet. So I don't know if it will yell if I don't do this, but I just want to make sure that that's done. So we're going to restart that, and it'll take a second to load, but that'll be perfect because we're actually just going to start migrating this again. So that, I think, loaded back up, or maybe not yet. But so we're going to go back to click OK on migrate, and then it's going to let us pick where we want to migrate that to. So I think I have it in this folder. Yeah, so I have Thruster project, and then you go and click the content folder, and the content folder is where you have to import it to. So you just hit select folder, and then it just automatically migrates it. So now if we go and look in our Thruster project, which is now restarted with the Niagara plugin enabled, you can see we have a lot of different things in here that weren't in here before. So it actually migrated not just the particle system, but all its dependencies, which we don't actually need for all this. You can see it migrated all like the modules and stuff for Niagara. So maybe I didn't even need to implement the plugin. I don't know. However, we don't really want all that stuff. So what we're going to do is we're going to find our simple system. And let me go see what folder that was in real quick. It was under example content. Okay. So under example content, Niagara, and simple. So we have the emitter in the system here. So we open it up, and you can see that it is functioning as it was before, perfectly fine. So what I'm going to do here real quick is I'm just going to delete all these other things that we brought in with it, because we don't really need them. I don't know if that geometry came in with it. So we right click, delete. It's going to ask you if you want to delete it. And then it's just going to delete everything. Geometry. Yeah, that's fine. Okay. So now if we look at it again, it's still working just fine because all of the dependencies that it brought with it were just dependencies from the stock Niagara stuff. So all that's still in there. It still works just fine. We can drag it out into the world. No problem whatsoever. So now we have this particle system imported into our project. And we're just going to make a couple little changes that will produce some big differences in it. So the first thing I want to do here is turn this to local space. Actually, just show you what that'll do. If I move this now without it in local space, the particles just move as I move it. They don't really stay together relative to each other. If I turn this local space on and save it, you'll notice that, oh, if I can find my cursor, it just keeps disappearing. That when I move it now, all the particles kind of stay together relative to each other. So all the particles are being spawned and moving in local space relative to the emitter location. So now we have that. The next thing that we want to do is go to the lifetime of these particles because they're living a little long for what we want. That was the wrong thing. Set variables and change lifetime from 4 seconds to 1.5 seconds. So now they live much less long, and you can see that the change in size is happening at a much more rapid rate since that sine is happening over the lifetime of the particle, over the normalized lifetime of the particle. So now that we have that, we're going to go down and we're going to start changing what this sprite size scale is doing for us. So you'll see what they're doing is they're scaling both the x and the y using a sine function and multiplying the normalized age times just a constant, a scalar. So what we're actually going to do is we're going to change this to a clamp instead of a multiply. So then we're basically giving it a range that we want to be in. But also what we're going to do here is we're going to make an expression. And basically what we're doing with this is we're going to customize the sine function so that it gives us a specific range so that we can shape it the way we want it to be shaped. So first thing we have to do here is type into this expression that we just made, particles normalized age. So we're still going to be going off the age of the particles, but then we're going to divide it by 2 and add 0.5 to it. And so basically, instead of getting a full wave with this, what we're going to do is cut that wave in half so we only get sort of an arc shape. So now if I hit enter, you can't really see it yet because I haven't customized all these numbers yet, but if I start tweaking these numbers, you'll start to see some shapes emerge. So I think probably around 1.8 or 2-ish should be good for this one. So you can see we're starting off larger and getting smaller. We want the scale to be much, much larger, so we'll go up to 7 to 8-ish. You can see now it starts off really big and gets really small really fast. And then you can see we have a little bit of this popping happening at the end as it's trying to go back into like as the values are increasing on the other side of the wave. So what we're going to do here is we're going to increase this bias to somewhere in the 4 to 5 range. And now you can see we have basically shaped this thing to be sort of like what you would expect the exhaust of a thruster to look like. I mean, we can definitely play with this a little bit more to change that shape to get it to kind of peak at the end a little bit more or something like that. So now you can see we have a little bit of a trail going. It looks pretty neat, and it's super fast to get from the stock simple system to this. So there are a few other things we want to do here now that we have that going on. You'll notice every time this finishes and loops back around, it has to catch back up. And we don't want that. So what you want to do is you want to go up to Window and you want to turn on System Details. This isn't always turned on, so if you can't see it, you can turn it on up here in Window. But it's a tab over here right next to the stack. And if you click on it, you can go down and there's Warmup. And basically what this is doing is it allows the system to run ahead of time before it is displayed so that it can get to a certain point in the simulation. So what we want to do is we want to warm it up effectively a particle's lifetime. So if we warm up a particle's lifetime, you'll see the entire shape of the emitter the entire time. The more you warm up, we could warm up for longer, but the more you warm up, the more resources this takes. So essentially what's happening is it's simulating the system in advance before it's being displayed. So if you did this in a particle system that's placed in a level and then like built into the level, then that warm up is going to happen during the initial load of the level. However, if you spawn these like procedurally via blueprint during, gameplay, then that warm up is going to happen as you're spawning the particle system. And if you do a lot of that, that can take a lot of resources up. So just keep in mind, don't warm up for longer than you need to. 1.5 seconds here is going to do us perfect because that's the lifetime of particles. So basically, the first particle is going to get to its death up here before we ever see anything. So we constantly get this full-looking particle system. So now we can go back. So we have the sprite size scale worked out. We want to give this a little bit of color. So, we can do all kinds of colors. If you look at sci-fi stuff, you can see all kinds of colors for these kind of thrusters, like bluish, purplish, a lot of orangish, reddish because that's the color of fire. I'm going to go sort of light blue, though. I think that's kind of a neat color for these sort of things, sort of stylized and interesting. And then we are going to scale this color by 5. So now it's much brighter. It looks like a light source. And you get this kind of interesting like plasma effect with this additive material we have on here. So now we have this pretty decent looking. This, in a low poly game, this would probably do the trick. This would look great. But you can do a lot more to kind of tinker with this to make it look even better. You can just play with the alpha curve here to give it kind of a fade off at the end. You could also, if this doesn't work for you, you can see we only have like 7 or 8 particles at once, which I've done intentionally here for the sake of having less overdraw. But if you really wanted to and you weren't going to have a bunch of these in the scene, you can just start cranking this up, and it looks more and more realistic the more particles you give it, because it really flushes out that shape to kind of make it look, like that teardrop shape that you see in a lot of sci-fi movies when you have a spaceship thruster. I'm going to go with 5 just because I keep it fairly simple here. But there are a lot of other things that you can do with this. So the first thing I'm going to do here is I'm just going to add a little bit of variability to the initial velocity. So you can see we're going straight up on the Z at 50 all the time, but we want to add a little bit of variability to the X and the Y to give it kind of a flux to it so that it looks a little bit more interesting. So we're going to split this vector and we're going to keep it at 50 on the Z, but we are going to add a ranged float to both the X and the Y. And we'll just go real subtle here. So we'll go -1 to 1 on both the X and the Y. So you can kind of see it here. If I crank up the samples or the sprite count, you can see a little bit better. There's there's a little bit of a wavy nature to it. It looks kind of neat. It looks kind of unstable. And you can actually do a lot more with this because, this is a pretty neat thruster effect, but you can also use the same shaping to get other effects very quickly, very easily. So for instance, if I left this on a higher sample count, like 10 or 20, something like that, and then I cut down the particle life to half of what it is and increase the velocity to, we'll say, 10, -10 to 10, -10 to 10 on the X and the Y, and 100 on the Z, you can see we get something that looks a little bit more like a fireball. And we can change the color of that to be a little bit more like a fireball. You maybe would want this to be less emissive or something like that, somewhere in the middle. So you can see this looks a little bit more like fire now. And we did that super simply. You could have this as a like a candle flame, or as a fireball. Like if you kind of turn your head sideways, it kind of looks like a fireball that's hurtling through the air. So you can really quickly like prototype out a bunch of different particle system types with this. And really the only limit there is your imagination of you know, what you can envision with this. So I'm going to change all these back to what I had them at before. And then we'll just move on real quick to one last thing I want to do with this. Did I change anything else in there real quick? No, I think all that looks good. Okay. So, actually I do want to change this color back. Okay. So now, one last thing I want to do here, which will make this a little bit more dynamic, is to expose a parameter in here that we can use to scale this, to change the shape and change the intensity of the effect over time so that we can feed things in via Blueprint to sort of give like a boost effect to this. So I'm going to click up here on System Exposed Parameters, and I'm going to get a float. And I'm going to call this float Thruster Throttle. And it's going to be 1 to start off with. But then we're going to go down and start changing some of these things. So I'm going to change all of these scalars here to multiply floats. And essentially what this is going to allow me to do, I'm going to put that at 1.8. I'm going to link that to the user variable that I just created, the thruster throttle. And we're going to do this for each of these. What was I thinking? Multiply float. That's right. I just sort of blanked out for a second there. I'm sorry. 7.5 is what we had about. We're going to go to a user variable for that. And then once again, multiply float. And this was 4 to 5-ish, so we'll go 4.5. And we'll link our user exposed variable. And then the other thing I want to do here is I also want to scale the intensity of the color, or the brightness, I should say, not the intensity of the color, because since this is additive, since I'm scaling the brightness, it's actually going to make it more white and less colorful. But we're going to multiply this vector. Whoop, no. We're going to multiply the vector by a float. And then do the same thing. So this was 5, 5, 5. And then we're going to link this once again to our variable. So now we have all these linked up, and now you can see if I go up here and I start messing with this value, I get this real cool, like it brightens and it expands out. So now very quickly I've added control to be able to start at 0, like start at the particle system is almost not even on, and then just flare it up really quick and then turn it back to normal. So just to kind of prototype this out in Blueprint, we can go here and we can just create Blueprint actor, and we'll call this BP. Wow, I can't type. Thruster. I'll open that, and then we're going to add a Niagara component, and this will be our simple system. I should have renamed that, but you definitely, like, if you were doing this in the content examples, you would have wanted to make a copy of this and name it something different, but it's fine for our purposes. So now I have this in here. I might actually crank up those the sprite count a little bit so it looks a little bit better. So now you can see we have sprite count cranked up. We've got our particle system in here, and now what we're going to do is we're going to add a timeline, and we're going to call this thruster ignition. We're going to open it up, and we'll put it on autoplay and loop, and we'll get a new track here, and we'll call this thruster throttle. Now what we're going to do is we're going to start off time 0 at a value of 0. We're going to go to time 1, have that be a value of 1. Let me scale this correctly. And then I'm going to add at time, I'll say 0.1, a value of 2. And now what we want to do is we want to turn all these to be automatic interpolation. And we'll add another key here and just kind of, that's not automatic, there we go. add another key here and just do that. And so now we have a nice little curve here that will drive this behavior. We can go in and grab our Niagara system and set float. And this will be user dot, what was it, thruster throttle. And we'll plug this in here, plug that in there. So update into this and then make sure you get this float and plug it into the end value. And we'll save this and delete this. That shouldn't be there. And plug this in here and rotate it so that it's sideways so it looks right. Now if we play and go look at it, if it's working right, there it goes. Whoa, that happened a little bit faster than I wanted it to. Oh yeah, that's right. This is, so I did a little goof with the numbers. This is over 5 seconds is what I meant to do. So we'll take this last point and we'll put it at 5 seconds. Okay, we're gonna drag this out a little bit. And drag that out a little bit. And maybe make that less dramatic. Okay, this should look a little bit better now that I have it over the right time scale. So now you can see that we have this initial little boost where it explodes outward and then it shrinks back down to its normal size. So that's, yeah, pretty neat for having an effect where you just kind of very quickly put something together, maybe for like a game jam, and you have a nice little detailed effect that you can put on your spaceships. And it's super simple to mess with any of these values. Since I made all these multiplies here, you can literally just drag any of this out and get whatever kind of effect you want, any kind of shaping that you want to give to it. You can do that. And you'll notice that there are some minor hiccups in there, but they're not too awful. But basically, if you just, the clamp is here for, you know, shaping as well. You can just shape things using that. Gives you a lot of control over this particle system, and then you can just change those things and come back, and that change is reflected. And since we're scaling things, it just automatically works, right? And so you take a look at it, it looks pretty good. There's some minor little glitches in there, like you see when it resets. You can see for a second those particles, because when you set things down at 0, it kind of breaks down the effect. So you'd have to spend a little bit of time to wipe those things out. But considering how much time we spent on this already, it's a pretty good effect for what we invested. So I hope this was helpful to you, and I will continue to make videos on these. I'm basically probably just going to work my way through each of the content examples, and as you can see in here, there are quite a few of them. There are like 15 of them, I think. So still some more videos to come on this stuff. If you have any questions about any of this, put it down in the comments below. If you have any suggestions on things that you would like to see, I'll also put those down in the comments below. And thank you for watching the video. I hope you have a great day.